Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the structure. The molecule shown has 4 carbons total. Reading the structure, there is a CH to Cl group attached to a carbon-bearing NO group, which is in turn attached to a carbon that bears both a methyl group and a terminal double bond, CH2 is equal to C. Moving on to the next step. Determine the parent chain. The longest carbon chain containing the principal characteristic group, O, and the double bond is 4 carbons, ClCH2CH, or CCH3, is equal to CH2. This gives a but 3 in a backbone. Moving on to the next step. Number the chain to give the principal characteristic group, or the lowest possible locant. Numbering from the CH to Cl end, C1 is equal to CH to Cl, C2 is equal to CH, or C3 is equal to C, CH3 is equal to C4 is equal to CH2. The O is at C to the double bond is between C3 and C4, but 3N2-ol, and the methyl branch is at C3. And for the final step, identify all substituents and their positions. C1 chloromethyl chloro at position 1. C2 hydroxyl ol at position 2. C3 methyl branch 3 methyl. C3 C4 double bond but 3N. Assemble the IUPAC name following the order: locant for halo substituent plus halo plus locant for methyl plus parent chain plus Na locant plus Na plus ol locant plus ol 1 chloro 3 methyl but 3N2-ol. There are no other structural interpretations since the chain length, the positions of O, Cl, methyl, and double bond are unambiguous from the drawing structure. Therefore, the correct answer is 1 chloro 3 methyl but 3N2-ol. The correct answer is shown on screen.